Okay, so we've been talking about some areas of different figures, and today we're going to go into the areas of some regular polygons. And yeah, you could find the area of that regular triangle on the left, and that makes you happy. And you can find the area of that regular quadrilateral, and that makes you happy too. And then when you're finding the area of that regular pentagon, you say, I don't have a formula for the regular pentagon, and you become sad. So fear not, my friend. I want you to be happy. So let's figure out how to do that area of a regular pentagon. And maybe we'll change some side lengths as well after that, and side measures and number of sides and all those good things. So first of all, we're going to define what's called an apothem. An apothem is the distance that goes from the center of the polygon to a side. So now let's think for a minute. If I say that like that point right there is the center of my apothem, or the center of my polygon, and I want to figure out the distance to the side, think about how I have to go along that path. If I'm going to go the distance, say, to the bottom of that, I need to go in a perpendicular direction. So yes, the apothem is perpendicular to a side, something to be aware of. So what's neat about that now is from that center, and again, I apologize for the exactness of my center, but what I can do is I can draw in two lengths there. So now what I can do is I can say that the apothem is the height of my triangle. I'm going to call that apothem maybe, say, A. And then for the side length, let's call that S for now. So then the area of that triangle is going to be 1/2 times A times S, whatever those values are. But that's not the only triangle we can draw. I can draw in this case 5 triangles. And those triangles will actually be congruent triangles as well. So then the area of my regular pentagon, which has 5 sides, is going to be 1/2 times A times S times 5, and whatever that works out to be. So now if we start generalizing that, let's think about what would change if we change the number of sides. The area of each triangle is still going to be 1/2 times the apothem times the length of the base. What's changing is the number of sides. So while for 5, it was 1/2 times A times S times 5, for 6, won't it be 1/2 times A times S times 6? And for 10, won't it be 1/2 times A times S times 10? So would it make sense then to generalize it? And if we have an n-sided polygon, an n-gon, that the area of it is 1/2 times A times S times n, where n is the number of sides. And if we even want to go a step further and generalize it for the perimeter of the figure, remember, perimeter is going to be the number of sides times the length of a side. So the number of sides times the side length, that's S times n. So maybe we'll say that that area is 1/2 the apothem times P for perimeter. Those make sense. Here's a conjecture to fill in. Our regular polygon area conjecture. This is how we find the area of regular polygons. Oh, yes, student sitting on the back of the room with his hand up. What do we do if it's not regular? We box it in. That's what we do. Oh, OK. Yeah, or we can divide that regular or the irregular polygon into other shapes that we know, perhaps. But for the regular polygon, 1/2 ASN works well for me. OK, you might want to get your calculator out so we can play a little bit of figuring out areas of polygons. Let's figure out what the value of A is. In this case, S equals 12 and A equals 14.5. Determine your area. So we know that A equals 1/2 times A times S times N. In this case, my value A is my apothem. So that's going to be about 14.5. S is the side length, which is going to be 12. And N is going to be the number of sides. And it's an octagon, right? An 8-sided figure. So when we multiply that out, did you get your area to be 696? And I guess because they gave us units, we'll say it's square centimeters. How'd you do on that one? Hopefully well. Let's try number 2. In a regular n-gon, so I don't know how many sides this thing has. But I know the side length is 4.8, the apothem is 7.4, and the area is about 177.6 square centimeters. So see if you can find out the number of sides. So the area equals 1/2 times 4.8, or 7.4 for our area, or our value of A, times our side length, 4.8, times N for the number of sides. So think about what we got to do here now. If we want to clear out this fraction, maybe we're going to multiply both sides by 2. And that's going to give us, let's see, I think 355.2 equals 7.4 times 4.8 times N. So now I divide both sides by whatever 7.4 times 4.8 is. Can you hear me pressing the buttons because I forgot the 1/2 in my original calculation? Oh no! So when we divide that out, you should get N equals 10. Oh, I didn't need to do that. See, I have the answers written on the board next to me. I wrote 5 because I forgot to divide it by 2. I should have just doubled it. Oh well. So a 10-sided polygon. Cool. We love 10-sided polygons. So one last one. Determine the exact area of a regular hexagon whose side length is 10 centimeters. So let's see. Let's draw ourselves a regular hexagon. Maybe it looks something like that. That's pretty good. So let's see. Side length is 10. We're looking for the area. Area equals 1/2 times the apothem. Oh no, I don't have the apothem. Side length is 10. 6 sides. Oh no, we can't do this problem. Yes, we can. Ooh. Well, think about what we're doing here. We're going to be drawing some triangles, right? Tell me something cool about those 6 triangles that I drew. Did you say that they were equilateral triangles? Yeah. So how does that help us? Well, think about what we just did. I'm going to take one of those triangles and draw in its apothem. So what I just did was I have that as 10, and it's an equilateral triangle, right? So what I'm going to do is then I'm going to draw in the apothem. Wait a minute. Doesn't the apothem create another triangle, a right triangle? It does. And isn't this side 10 and that side is 5? And wait a minute, because the original triangle is equilateral, isn't that 60 degrees? Isn't that a 30, 60, 90 triangle? Yes, it is. Oh, lovely. So how long is that longer leg? How long is the apothem? Yeah, the apothem is 5 radical 3. Love it. Oh boy. And because it says exact area, I am not doing any decimals there. So let's see, when I multiply all this out, let's see, half of 10 is 5. And then 5 times 5 is 25 times 6 is 150. So my area is 150 radical 3 square centimeters. Oh, love the hexagon, man. So hopefully you feel pretty good about finding the area of a polygon. Now let's get going with our practice work.